So I'm a lecturer here at Uni Melb. I've been here since the end of 2018. Normally I teach electronic circuit design. I've done that for a few years now. And so I guess this year we're designing this new course, Semiconductor Devices. So this course is essentially trying to have a bit more of a sort of detailed look at the materials aspects of semiconductor devices, getting a little bit more into what's really happening at the electron and hole level in these materials, that types of thing. I guess so. I mean, it's a completely new course, so that's exciting. And it's one that hasn't been taught at UOM before in the whole history. And perhaps on a more personal level, I mean, it's my personal area of research as well. So I work on devices myself. You know, all my PhD students have topics in devices. I go to conferences in devices. You know, I have a lot more background in these types of areas and have been working in this field for, well, more than 10 years now. I mean, this field moves so fast. It's there's so many different devices, right? It's not just what we learn in the master's course. And in each one of those fields, there's sort of a forefront, right? And that forefront is moving very fast. Like even, you know, for example, my own fields, I work in photovoltaics and I work in nanoelectronics. Like you have to keep an eye on it. Every week there's a new paper that might be something that you've been working on for a year and you're like, you know, is this going to overtake what I'm doing, sort of thing. So it's really fast moving. So I guess this course kind of fills a gap. And if you were to find the edges of the gap, then EDM would be on one side and ECD would be on the other side. So I guess we go a little bit more into the materials side of things. We start talking about Fermi-Dirac statistics and we start talking about energy band diagrams and what's happening at interfaces and things like that. And we also cover some other devices that aren't really covered in other courses. So things like solar cells, we spend a bit of time on, you know, that's sort of my personal interest. So I've inserted quite a bit of it in there as well. And I guess I noticed this gap, and others have also noticed this gap teaching ECD, because, you know, you're teaching ECD and we start talking about current flows in diodes and BJTs and just get this vacant expression from students in the class. And it's a real shame because you don't have the time to go through that, you know, that detail. So yeah, I guess this is sort of in reaction to that, to try and give a bit more depth there in terms of, you know, what's going on at that electron hole level. So, I mean, this is the first year we're running it, and it's unfortunate that it's also coincided with this sort of remote teaching type thing. So we have big plans going forward for the workshops. In this first year, we're going to use the workshops as a way to train students up on a software suite called PC1D, which is a freeware software, which essentially allows you to sort of build a semiconductor structure and then, you know, set it going and simulate what happens when you apply some stimulus to this semiconductor structure, and you can see, you know, how the bands bend and electrons and holes move around and things like that. That'll be most of what's going on in the workshops. I think that it's suitable to anyone as long as you've got the prerequisites, and even some of those who don't have the prerequisites, if they've done, you know, some courses that are sort of similar that fulfill that, then we'll also give them an exemption to come in. Yeah, it depends a bit on what your interests are as well. I mean, if you're interested in working in devices, in manufacturing, you know, these big companies that do these kind of things, then it's probably a good course for you to do. So, for example, if you wanted to go and work for the PV industry or for the microelectronics industry, then I think it'd be a pretty essential course, and that's something that you would be asked in your interview, right? Maybe they would ask you to draw something, you know, how does a MOSFET work? Draw a MOSFET in this condition, something like that. I guess it depends on the pathway that you're going to, but I think if you're in any way considering working on devices, then it's really important to have that knowledge. And even if you're working on the system type stuff, it's not going to do you any harm to have that knowledge as well, right? To have that understanding about what's going on. And also, if you're interested in the other way, if you're interested in doing a PhD or further study in device level stuff, then it's definitely a good course. I'd say probably essential for you going forth. It's got a little bit of mathematics in it. I've tried to cut a lot of the quantum mechanics out because, you know, we can get a lot from just introducing the fact that that's what's happening, and then you get some general equations for it, and then that's where we start in the course. But yeah, I'd say it's got a good mix of both. It doesn't really go into the system side of things, so we're only ever looking at an individual device. We're never looking at, you know, for example, in ECD, we're looking at a stage, right, with a BJT, with a resistive network or something like that. So we're just focusing on the actual device itself. And yeah, so there's a little bit of mathematics in there, but it's not too strenuous. I mean, examples of fields that are really fast moving within devices. I mean, PV has always been a big one, so solar cells. Lots of things are changing in solar cells now. The industry sort of for the last 25 years had this same architecture and it worked really, really well. And then in the last 6 years, things have just gone crazy and everyone's trying lots of different things. And so, yeah, lots going on there. And then, I mean, there are other fields as well. Think about MOSFET scaling, you know, the emergence of 2D materials. You know, is this going to become a thing? Are we going to start using this in computers? Overlaps with on-body sensors. That's become a really big topic. You know, the human-machine interface has sort of overlaps in this area. Yeah, I mean, you choose 100 things. Ask a different person, they will give you a different answer. But yeah, lots of exciting things happening in devices. Yeah, so it's not, we don't really assume a lot of knowledge in terms of materials, and we go through it reasonably slowly. So that's, I wouldn't be very concerned about that myself. There's a little bit of assumed knowledge, but that's kind of probably what a lot of people got in their undergraduate or even in their high school. You know, what's a semiconductor, what is a band gap, things like that. And even if you don't have that, then at the end of the first lecture, you know, there's some resources that we give. So you could start and you could read through and you could see if it was too much for you to catch up or not. But I think that most people in the program would have no problems, you know, if you've got the prerequisites starting from nothing, sort of thing. So I'm co-teaching this course. So the first half is taught by me and the second half is taught by Ken Crozier. And so in the first half, you know, it's maybe a little bit biased. I've made one of the workshops on photovoltaics, and there's a couple of lectures on photovoltaics as well. So, I mean, there is a direct link where we talk about industry and, you know, what's the sort of standard in industry and trying to get an understanding there. And Ken's got similar sort of tie-ins in his areas as well. I would say that this semester, I mean, it's the first time we're running it, and you know, there's hesitation there as a student. You don't know. They're running this for the first time. Everything's not going to run so smoothly. And yeah, of course, that will be true to some degree, but there's also real positives to doing it in the first year. And that's that we have a lot more time. You know, we sort of have this unofficial allocation, right? Because we're starting a new course, we can devote a lot more time and a lot more resources to this. And also the cohort will be smaller as well. It'll be a smaller class. It always is the first time you run it. So you'll get comparatively a lot more attention and sort of, you know, face-to-face interaction. If you join it and there's something that you don't like, then tell us straight away.